Problem 1. So I'm going to read it off for you. And you can see I'm already setting up a rice table because I need to move here and I've only got so much board space. So I've got sodium hydroxide, hydroiodic acid, making water and sodium iodide. And I've got the molecular masses at top. So if you start off with 15 grams of sodium hydroxide and enough high to react with it, how much sodium iodide can I make? And then if I make 50.2 grams, and that should be of NaI, what's my percent yield? Is this okay? Why or why not? So 2 parts. First part is we've got to do a stoichiometry problem. And deciphering here is I'm saying we've got sodium hydroxide and enough HI. I'm not asking you to do limiting reagent. I'm saying, oh, Dr. K is giving me a mass and then saying we've got enough of this stuff. I only need to figure out moles here. Cool. Okay. So how much sodium iodide can I make? The second part is saying, okay, now we know we've made this much in the lab. Well, what's our percent yield? So let's see where we can go with this. So the first part is always the same. We got to get moles. It doesn't matter if you're doing old school math and dimensional analysis or a rice table. So let's do it. So if you take 15 grams of NaOH and say, hey, 1 mole of NaOH has a mass of 40 grams. That's going to give you 0.375 moles. Well, it's a 1-to-1 reaction. I've already set up my rice table. Let's see what we get. R, I, C, and E. Boom, boom. So these are my products. We know that we don't have any of those to start off with. We know we've got 0.375 moles, and we've got plenty of this, so we can just put 0.375 in there to make the problem work. So change line, well, we're assuming in this one that we don't have a limiting reagent, so all of these will disappear. It's a 1-to-1 reaction, so equal amounts of our products will up here, but we're really interested in the sodium iodide. So when we're done, goose eggs for the sodium hydroxide and the hydroiodic acid, and 0.375 moles of water, and 0.375 moles of sodium iodide. Well, how much mass is the sodium iodide? Same thing we've been doing for the past couple weeks. 0.375 moles of NaI times the molecular mass of 150.9 grams per mole. Moles cancel, and that gives you an answer of 56.6 grams. Okay, so that's how much, if we're perfect, how much sodium iodide we could make. Let's get to the second part of the problem. So the second part is the percent yield part. And we said, okay, percent yield is how much we actually made versus what was possible. So when we read the problem, we said, well, we made 50.2 grams. That goes in the top line. That's what you did in the experiment. That's what actually got produced. This is what you calculated by stoichiometry and said, hey, we could have made 56.6 grams. That goes in the denominator. 50.2 divided by 56.6. And you can leave these as decimals. I routinely do that, but let's make it, a percentage like we're used to seeing, multiply by 100. So you get 89.2%. And you stop. Is this possible? And yes, it is. Why? Well, it's less than 100%. It doesn't mean you didn't mess up or didn't screw up. It just means that it's possible. How do you know? Law of conservation of mass says You can't end up with more than what's theoretically possible. You can't create matter out of nowhere. This isn't Harry Potter, there's no magic. So you can't go over 100%. A balanced equation still means something. Pieces still have to equal pieces. Oh, we're 89.2%. That's actually pretty efficient. It's less than 100%. It's possible. Doesn't mean you didn't mess up someplace. It doesn't mean you don't have contamination, but at least means you can breathe. God, guys, I'm sorry. It means you can breathe a little sigh of relief because it is possible. Okay? I'm going to show you how this works with a limiting reagent problem, and then you get cut loose on this. And then I do have a couple of example problems for you to refer to that aren't in the video. Back in a flash.